All right. Thank you for that fantastic introduction. My name, again, is Benjamin Jeter, and today I'm going to be talking to you about a reference architecture pattern that I found very useful. Just a little bit about me. I'm staff data architect, platform manager, data engineering, data platform team of one, and I work on the EDR, so endpoint detection response product at Datto. And just to get started, uh, I would like to touch on the title that some of you may be wondering about, and that's a reference to Flatland, A Romance of Many Dimensions by Edwin Abbott Abbott. And I think it's a helpful metaphor for thinking through basically the different aspects of what we should always be doing when we're working on the design for a data platform. The story and general conceit of this book is there's a square who lives in Flatland, and one day he is he comes face to face with a sphere from Spaceland, so 3 dimensions, and then travels through the different dimensionality that exists within our world. And that's really the metaphor. So, it can be very easy to get focused on a very minor technical point and get very in the weeds. And I know that we've probably all done it on this conference. But it just serves as a reminder to think about the implications that small changes have on the overall deployment and really the effects that could have on your end users. So today I'm going to be walking you through some of the considerations and the design goals that are behind this reference architecture and why I chose to use Galaxy. And I can briefly touch on that, but I am deployed on Starburst Galaxy, and it's been fantastic, really, again, as a data team of one, being able to offload that management of my cluster and deployment in general to the great folks at Starburst. So next, I'm going to be really going through the actual architecture, talking about what I am and am not solving. And this is where typically you would see diagrams, but the security folks suggested strongly that they not be included, and so they will not be. So before we dive into the actual reference architecture pattern that I'm going to be talking about, I think it's helpful to really think about what it means to say this is a reference architecture pattern. So I really like to think of it as a modular pattern that can be used in a variety of different situations to accomplish a particular task. And so I know that's very generic, but I think it's helpful to have patterns as an abstraction in your toolbox in order to then deploy them as you see fit and as fits your use case. And it's also going to be opinionated. This is a question of design, and there's always going to be different ways to approach a problem and different ways to solve things. And, that's absolutely fantastic. And we're here to learn from one another. And really, to that point, it's more so a conceptual tool than a specific, this is how you should go about doing this one particular thing in this one particular use case. So I'm hoping to really speak to the generic, but also give some concrete examples of how I'm solving what I'm solving. And, I'm ingesting and managing billions of records coming in every day. So this needs to be simple, but it should also be effective. What it's not, a hammer. So this is not a pattern that's going to work for every use case. And I think that it can be easy to fall into that trap when you see something that looks really fantastic on the surface of it, and then you try to apply it to a broad variety of different situations without really interrogating what makes it useful. And it's not necessarily going to be the best solution for your use case, but it could be, and hopefully it's thought-provoking enough to help you expand that toolbox. And this is a lightning talk, so there's not going to be a full systems overview for your data platform. Policy, access control, all of this kind of stuff are clearly out of scope, but just a reminder that that stuff's important too. And it's not going to make you toast, but hopefully it will mitigate those pager duty alerts so you can wake up and make your own breakfast without having been up for 6 hours at 9 a.m. So moving on to some of the design goals, I have 3. This pattern is going to facilitate near real-time data access, which is what everyone wants as a stakeholder, and as architects and platform owners can be difficult to achieve at times. And I am going to do it with Trino, and in this case, Starburst Galaxy, and an orchestrator of your choosing. So Python or Airflow, Luigi, that kind of thing. Secondary goal is it should be simple, easy to understand, and the complexity is always going to be there in the implementation of a solution, but the overall thread of how it works and why it works should be simple to understand. And that helps explaining things to stakeholders when you're debugging things and pulling your hair out. If you are able to look onto a simple pattern or onto a pattern that is fundamentally simple, that's going to be a big help. And it should be modular, adaptable, flexible. Business needs change, and I've certainly had the experience with overly complex architecture patterns that just really, really slow things down when there's a new business requirement. And again, just noting that processes are typically just as important as design patterns for actually implementing and making the data available. My third goal here is the smallest viable stack, and I've got it down to a very, very small set of technology. Again, just Trino and an orchestrator. And I really wanted to not rely on Spark because it's expensive to run. I'm writing Spark SQL anyway, so I figured why not just do this with the Starburst cluster that I have deployed already. And the other nice thing about this, as much as I love Trino, and I think all of you do as well, this is totally portable. We're using Iceberg tables, we're using Hive, and we're using a query engine and an orchestrator. So any of these different things, you can take out, rebuild, do whatever you need to. So you're not bound in any way with this pattern to using Trino. And I think that that's always an important consideration when you're making decisions that could be very, very long-lived on your data platform. And finally, and this is the opinionated part, the orchestrator should orchestrate, and that's all it does. So it's going to tell, in this case, Trino to execute some SQL, and I am certainly a big proponent of not doing any kind of data manipulation in nodes of your DAG. So for those of you out there doing that, my opinion is save the pandas for later. So what we're going to do, facilitate real-time data access. And what does that look like in practice? There's going to be a couple of steps. So let's say, for the sake of this presentation, that you have a landing zone and data is landed in Hive format with, say, created date equal 2023-01-01, etc. And let's just say that it's JSON. And then we're going to use Trino to query it. And then you draw the rest of the YAML, which is what we're about to do. So this is what we're going to do first. We're going to have a daily batch transform that's going to be managed by our orchestrator. That JSON is going to be transformed into Iceberg. And this is going to serve all of our T-1 data. And it's really as simple as that conceptually. Then we have an external table that is rebuilt every day as part of the daily batch transform. And the nice thing about unpartitioned external tables with Trino using the Hive connector is that it has scan on query semantics. And that means as soon as data is landed into your object store, it is available to be queried by your end users. So this is basically as real time as you can get it without streaming solutions such as like Kafka or Kinesis or something like that. And again, smallest viable stack. And we're going to do something real clever and union these two things together. And the Iceberg is going to serve all of our T-1 long tail analytics queries. And the external table, which is again rebuilt every day, is going to serve intraday data as it lands. And then access, this is another important feature of this pattern. We're going to use views. So users are never going to have access to the physical tables. They're always going to be querying everything via an exposed view in a governed zone in my deployment. So there's a few nice things about that. We can leverage invoker rights. So I'm sure many of you have RBAC set up, your role-based access controls, and using views like this, if you have some sort of like global temporary schema for prototyping or team schemas or things like that, you can rest assured that anything that comes through data exposed via your governed zone, if it gets put somewhere with maybe a join, it could potentially be exposing data to users that shouldn't be seeing it. your authorization is going to then flow through your view right there. And it's going to be helpful in reducing your management overhead. So you have a view, and that means that you can transparently play Mario and replumb everything as needed when there's an issue with your DAG, or if you're working on enhancements or anything like that. Say you are monitoring your query patterns and you notice that there's a bunch of new joins being performed on a particular field in your deployment. Just transparently update your bucketing strategy. And that's one of the nice things with Iceberg, is that you can do that with a live table. If you need to roll back or do a schema evolution on the physical table, you can promote that up to the physical level and then manage the rollout with your views. So that's super nice. And being able to do all of this work and then say, hey, stakeholders, guess what? We've had enhancements X, Y, and Z, and there's no action required on your part. And I found that that's something that's always been really, really appreciated by my users. So here is the big reveal, what this all looks like. And I would just say that the simplicity of what you're looking at right now obviously belies a complexity of implementation. So this is something that would be the final step, and this is the final step in many, if not all, of my DAGs that I have deployed at the moment. But there's like 15 or so steps. Maybe 6 or 7 of those are just making sure that the Iceberg table is being updated correctly and the data quality checks are happening and that sort of thing. And that is just something that I want you to take away. So yes, this is clearly very, very simple. We have up here, we have our catalog production schema. This is where our consumption layer is. This is your govern zone. And then a view with whatever naming conventions that you like. And, no one at me about the leading commas. I like them. And then you're going to pull from your hidden schema. You've got your Iceberg table and your external table that's rebuilt daily and defined on that single Hive partition. So using this pattern as the last step is something that I always design my pipelines to move towards, so that I get all of those nice benefits of being able to manage things with a view abstraction and then get all of the nice features such as real-time data access and that kind of thing, and also the simplicity in management. And that's really all I have. And I know that I'm a few minutes under on a lightning talk. So if there are any questions, I would be more than happy to answer them at this time.